Hello and welcome to the Math Bender. I'm Adnan Zaidi, and in this session we'll discuss math-related trigonometry and specifically area of triangle. Before starting off with the area under triangle, we need to understand what area is. So area is the amount of space any two-dimensional object occupies. For example, is just a random figure, and the amount of that light shaded area inside this figure is the amount of space that it has occupied on that space, and hence it is the area. Specifically, if we want to find out the area of the triangle, and let's say if this is a right angle triangle, this marker shows that it is a right angle triangle, and this is the height and this is the base. So we all do know that it is 1 over 2 times base times the perpendicular height. Always remember the perpendicular height has to be there. If it is a triangle in this form, so the perpendicular height is this, which we tend to don't know at times. So if this is A, so we can write this area as 1 over 2 times A times height. But let's say if we have a situation like this, and this here we don't have height, let's call this as A, this as B, and this as angle X. There is some angle given to us, and we need to find out the area, the amount of space it is occupying, and we don't have a direct height. So let's roughly construct a direct height here. So I could say that this is height. So as you could see that I have, if I've taken that height, this is as the height, and this is X, this is A. I haven't written down anything as this side because I don't know what that is. The whole length is B, but not this one. So I can say that in terms of X and A, this height can be written as sine of angle X equals to opposite over hypotenuse H over A. If you want to catch up with this identity, you may want to look up previous videos before coming on to this one. So A times sine of X is equals to the height, and I can write this as H equals to A sine of X. Now applying the same old concept, A is equals to 1 over 2 times base times height, this one. And now we know already the perpendicular height, so area can be written as 1 over 2 times base is B, the whole thing, times height we already figured out as A times sine X. Now this is the area if the direct height is not given. So rather than actually finding out the height every time by applying trigonometric ratios, we can directly come up with an idea that area can be expressed as 1 over 2 times the product of both the sides that are given to you, A times B, times sine of the angle that is in between, which is this one. And this identity can be applied on any situation. For example, if we have a triangle, and let's name this as X, this as Y, and this as Z, and these sides A, B, and C. Now I can write area is equals to, since 1 over 2 times A times B. Now note that if I'm taking these two sides, then sine of included angle, which is in between both of them, is x. This is as same as 1 over 2 times B C sine of, now the included angle between B and C is Z sine of Z. And you may want to write down the third option as well, 1 over 2 times A times C sine of angle Y. All of them will give you the same exact answer. So the idea is, rather than remembering the formula, all you could do is you need to multiply any two given sides and an included angle. Let's see some of the examples if we could try. Now this first one, as you could see, the area, I have two sides given and there is an included angle which is in between. So I simply, rather than finding out an independent height by applying Pythagoras or trigonometric identities, I straight away write 8 times 9 times sine of angle 72, and this gives me the area. So straight away, if you write this down as 1 over 2 times 8 times 9 times sine of 72. So the area is equals to 34.2 centimeter square. Let's look at this another example here. Now as you could see, the two sides that are given are 10 and 9.5, but I don't have this angle, and I need to have this angle in order to apply that identity. Now I can find 180 minus 62 plus 57 if I add both of the angles and subtract it from 180. So 180 minus 62 minus 57 gives you 61. So now you have the angle, and you can straight away apply 1 over 2 times 10 times 9.5 times sine of angle 61, whatever the answer that you get. Now let's look at an example where multiple things are applied. Now the figure shows a plan of two neighboring states, and there are two triangles. You have to find out the whole area of these two states. So as you could see that I have one triangle like this, and two sides of that green triangle is given, and there is an included angle as well. So I write area 1, let's call this figure 1, and let's call this figure 2. So area of one figure can be written as 1 over 2 times 202 times 112 times sine of angle 30. And straight away, so 202 times 112 times sine of angle 30, whatever the answer that you get, you divide by 2 because there's a 1 over 2 there, which gives you 5656 meter square. Now for the second area. Now for the second area, I can say that I'll use these two sides. So these two sides are 1 over 2 times 202 times 197 times sine of 60.5, and I can find it as and then divide by 2, which gives you 17317.5, rounding it off to one decimal place. Now the total area is the sum of both the areas. So 5656 plus 17317.5. Now looking at another figure here. Now it's a mixed question where all the other things are applied as well. So let's look at this one. So if you see this question where you have to find ACD, the first step is highlight what that is. So if I try to highlight what ACD is, I start from A, C, and D. It's technically asking for this angle, and it is a right angle triangle. So whenever there's right angle triangle, the tool bag that we have is either we use trigonometric ratios or we use Pythagoras theorem. But Pythagoras theorem is only applied when we have to find the third side and we have two sides given. Here we just need to find the angle ACD and specifically angle C. So according to angle C, we have the opposite and we have the hypotenuse. And we know that sine of angle C is opposite over hypotenuse, which is 3.7 over 8. And C is going to be sine inverse 3.7 over 8. So let's try applying it. So shift sine inverse 3.7 over 8. So the angle C is 27.5. You can write that. Next thing, you have to find the length of AB. So highlighting that length, it's this one. Now that is as well a right angle triangle, and according to the angle 40.4 which is given to us, this length is the adjacent and that length is the hypotenuse which you have to find. So the ratio that caters to adjacent and hypotenuse at the same time is cos. So I'll write cos of angle 40.4 is adjacent, which is 8 over hypotenuse, which is AB. You may want to write x as well if you want. That's okay. AB is 8 over cos of 40.4. So AB is 10.5. Now the area of the triangle AED. Now the area of the triangle AED, this is the area, this is the triangle AED, and it's not a right angle triangle. So if it's not a right angle triangle, we can simply see that there are two sides which I already am aware of, and this angle that is included. So I'll straight away write 1 over 2 times 3.7 times 4.1 times sine of the angle 55.1. So the area is going to be 1 over 2 times 3.7 times 4.1 times sine of 55.1. So the area is 6.2 centimeters square. This is it, and in this lesson we talked about how to find out the area of a triangle which is not a right angle triangle, although you can apply that in right angles as well. It's the same concept, and we derived the formula from the right angle triangle concept. Until then, I'll see you in our next session with a new video. Until then, take care. Bye.